Well, it says we're up on X, but I'm not sure we are. Let me look.
YouTube.
What was that?
You're on YouTube.
Okay, yeah. Let me check X out.
Got the dial set, coffee in my hand, MC. Signals in the air from across the land. A shack, a screen, and a vibe so
Hello, Brett.
we're going
Welcome.
live again this
Evening.
Tuesday night. It's not just static, it's a call
I've been finding dinosaurs.
where legends
All right.
hang
Yeah, I
and
see.
the airways blaze.
Let's see.
Hit the stream, yeah, don't be late. The round table's rolling. It's gonna be great. It's
Yeah, I'll have Godzilla.
show online. Amateur
Yep.
radio roundtable every time.
Oh, God, you want Godzilla? Okay, I think we can do that. Hang on.
With hams
Oh, she's in the other room.
whirling the vibe. With Glenn K.
All right.
Here you go.
All right.
Yeah, I've got Godzilla and King Kong both.
And wearing that crown. And Brent WY7BG shouting clear.
All right, I just verified. We're not gonna be on X tonight. You know, it's funny how these guys that own these companies like X and Facebook, they can change things and not tell you about it until you get ready to use it. I log in here tonight to try to get on, and X is telling me I got to go through all this verification again. I got to do a driver's license and a photo, and I got to mail it here and click here, and I just can't get it done before this. So we're minus X tonight, but that's okay. If you're out there listening on shortwave on WBCQ, this is Amateur Radio Roundtable, and it's a show about ham radio, shortwave, electronics. We're glad to have you tonight. Send us an email and let us know where in the world you are. Send that email to Tom at w5kub.com, and we're glad you're with us tonight. Let's see what else. Oh, the show will start in about 7 minutes. So this is pre-show. The ham radio show will start in about 7 minutes. In the meantime, you can listen to the Roundtable Band.
Shouting clear, coming strong from ear to deal. And Mark P, yeah, he's part of the light. So tune in every Tuesday night. Turn it on, let it play. From the heart of the hobby, night or day. Voices rising in the air. We're connected everywhere. It's the best ham radio show online. Amateur radio roundtable, real time. From Tom, Glenn, Brett to Mark P. They're the crew you want on your screen to see. So hit that stream and lock it tight. W5KUB.com. Tuesday night.
All right. Hey, Brett. You ever receive anything on your meshtastic?
Myself.
Oh, you did? Well, I'm not smart enough. I sent a few things out, but I'm not smart enough to know if I received them or if it just shows I sent them.
Well, if you don't see any nodes listed on your list of nodes, it's not connecting with
just
anything.
go to that.
Otherwise, it might be.
Tom W5KUB's in control, streaming the show.
Yeah. If we may have some time to talk about this with our expert, Glenn, on here. We'll do that after we talk about the antenna modeling that we're going to do tonight.
Yeah.
And if you want to talk about the 60-meter band, I've managed to
Trust
find
me.
a new band plan.
Okay. All right. We'll do that. We'll do that right after we finish with the modeling presentation. So Stephen, we'll get Stephen on here first.
W5KUB.com Tuesday night. There's a chat room buzzing, full of cheer and talk with the hosts, they're always near. Building antennas.
Well, let's see who's out there in the chat room. I see AC5CM's out there. Hello, Chris. KD5PUR is out there. Who else is out there? Mark P. And, of course, WD8IOL. James, he's always there. Appreciate you guys tuning in. All right, I got to hit I got too many buttons to hit. I just hit the Facebook button to get it going.
Old friends, new voices, call sign, shine. On the round table, we all align. Every rig and every key tells a story wild and free.
All right, I see the new band plan there. And that is VFO there in the center, isn't it? Yeah, it's got to be.
It is. It's VFO. It's 15 kilohertz worth of VFO.
Whoa, wow. Back when I was a novice 60 years ago, I could probably hit that entire bandwidth there. Going up and down as it drifted, you know.
Yeah, but now as your radio may not let you. That's one of the problems.
Yeah.
Your radio.
Gonna have to.
You had to modify it out of band, probably. Yeah.
Redo first.
Hang on one second here.
CQ on the air tonight. Roundtable's lit and the signal's tied. The static fades, I twist the knob. The shack comes alive, this is my job. LEDs
Facebook.
antennas high, another night beneath the
YouTube. I'm looking at. Looks like we are on Twitch TV tonight. All right, I'm gonna. I don't think the X is working, but it shows we're live. I'm gonna go ahead and kill that one. Stop number 3. Okay. Okay. All right. We got about 2 minutes. Yeah, we'll start in about 2 minutes.
Okay.
Has everybody met Stephen?
Hello.
W2WF Stephen. He's out down in Katy, Texas.
Katy, Texas. Yes, been there. Near Houston.
Yep. I got about 1 minute here.
QSLs, we got more ham than a southern belle from KWU5GP to Doobie West 7BG. We're working the world wild and free.
All right, we got about 8 o'clock almost. All right, we got 8 o'clock. I'm going to go ahead and get started here. Hey guys, welcome to Amateur Radio Roundtable. Hey, tonight we got a good show for you. We're going to be talking about probably a little simpler antenna modeling program. We got someone that's going to present that and show us how to work it. We got some information on the new band plans. The FCC has given us a new band. Well, kind of sort of a new band, not a wholly new band, but they've given us some more frequencies, that's for sure. We're going to talk about that. Hey, I got one meshtastic node up. We might talk a little about that tonight, and we'll probably get into a lot of other things maybe if we have time. So let's get ready for Amateur Radio Roundtable here.
It's the best ham radio show online. Amateur Radio Roundtable every time. Tom W5 KUB keeps the stream alive. With hams worldwide, we're feeling the vibe. With Glenn KW5GP breaking it down. Building gear and wearing that crown. And Brett WI7BG shouting clear. Coming in strong from here, DD. Oh, and Mark P. Yeah, he's part of the light. So tune in every Tuesday night. It's more than mics and modulation. It's heart and soul in every station. From kits and code to satellites. We learn, we laugh, we share the nights. So grab your rig, grab your crew, it's always something cool and new. No matter.
All right, we are back, and man, it's been interesting. Hey, it's been an interesting week here. Our temperatures got down here to like 2 degrees below zero. That's chill factor. I think the low was around 18 or 19, and then hey, I understand the next 2 or 3 days we're gonna have a heat wave, 25 degrees above normal, is what I'm hearing. So man, it's crazy here. Hey, you're watching Amateur Radio Roundtable. This is a show about ham radio, amateur radio, shortwave, electronics, just about anything here in between. And we're so glad to have you tonight. If you're out there listening on WBCQ Radio, you're actually listening to us on a Thursday. But if you'd like to join the show live, we are live on Tuesday nights, 8 o'clock Central Time. Just go to w5kub.com, and you can watch the show. And we also have a chat room there where you can chat with us directly during the show. I don't know where you're watching tonight. We're on a number of different social media sites, but if you do have a subscribe button, please hit that subscribe button. It doesn't cost you anything. We'd love to have you click that. It helps us advertise the show to other people that are out there looking for content about ham radio, electronics, and so forth. Let's see. Hey, join our Facebook group. We've got a great Facebook group that follows the show here. And just search for W5KUB on Facebook, and we'll approve you and have you in there before you know it. We've got right at 15,000 members in that group right now. Let's see what else. We're on just about every podcast audio carrier out there, from iHeartRadio to iNet to Google Play. You name it, we're on it out there. So we are in a lot of places out there. So we're so glad you're with us tonight. And so we're going to just go ahead and get started here, and let's go around the room here real quick and see how everybody's doing, and then we will bring in our first guest, and we'll talk with him a little bit, and we'll get on the subject of antenna modeling. So let's see. Let's get Glenn up here first. Looks like he's asleep. Wake up, Glenn. Wake up. Unmute your mic.
Yeah. I was writing, making some notes.
Yeah.
And,
Well, how you doing over there? Well, now, no. Hey, Glenn. No. How do I say this politely? No specific detail about the surgery or
No
anything going
details
on.
of
Okay. Keep the blood. Keep all that stuff
week,
out of it.
yes.
But how you doing?
uh,
So you can't report. You can't
I'm doing
report without
good.
saying
It's
it, huh?
Pretty much. I was going to say, I can't tell you a whole lot other than I went to the hospital. They gave me lots of good drugs, as I think was evidenced by the tried to use in chat last Tuesday night. But now it was elective surgery at all. And today is out the first day you could say that I'm pretty recovered from what it was.
Yeah. All right.
And so it'll be to get around and do things. So, That started to work on cleaning up the ham shack a little bit, getting it ready working. Got a guy lined up that's supposed to be coming around and put the tower for me. And once that happens, the tower can go up almost. So we're getting there slowly.
Do you think you're going to have that tower up before? Well, not you probably won't before Christmas, but before spring.
With these warm temperatures, I believe the guy will probably come by and look at digging the hole, and if we can get the hole dug and the temperatures hold, we can get the base put in.
All right, well, that sounds
good. That's the big
good.
thing. Everything else is nothing but bolts and whatnot. It's got an automatic winch to up in height, and it's got a hinge from horizontal to vertical. So, I mean, it's fully ready to go.
All right, well, good. All right, let's jump down here to Brett in Jurassic Park.
There we are. Actually, it's Godzilla and King Kong, which feels like what I've been dealing with, the fight of the kaiju these days. And there was warm weather here. I think the heat wave that's going to hit you, Tom, has already hit here, because we've had temperatures that are unseasonably warm in the 40s and 50s. And so I was out on the rooftops installing 5 gigahertz gear. So just this afternoon, before I came home and got back to my desk, I was aiming a 5 gigahertz wireless radio for someone who just moved into the area, and we had him on the internet in about 2 hours.
Okay, that's good.
Now that's part 15, not part 97, but you still need a lot of ham radio savvy to do it, because you need to understand antenna gain and other things about propagation. So I calculated things all out for his site, and the calculations worked. So that was a good thing.
Well, that's cool. Well, hey, what a lot of our listeners and viewers may not know is Brett there is the founder of the first, wireless internet provider?
Yep, the first what they call a WISP, a wireless ISP, in particular a terrestrial wireless ISP. So before you could get internet on your cell phone, we were already using microwaves to broadcast internet service to people. And people in Wyoming, where we have large distances and an average population of 5 people per square mile, could get internet service even if they were way out in the middle of nowhere, way outside of town. We're still doing it, even though now people have other choices.
So when you first started that up and you got people on the internet, what kind of speed did you start off with the microwave area? I mean, 33K or something like that, or were you higher? Or
our original network worked on something very early protocol developed by Lucent, which is called WaveLAN. It went at 2 megabits per second.
Wow!
And it was on 900 megahertz band. 900 megahertz band isn't that usable nowadays because so many slower things are on it, and they drown out the ones that are trying to go faster. It's great for meshtastic. It's great for things like baby monitors or power meters, but it's not so good for wireless ISPs anymore. But that's where we started. And then we moved to 2.4 gigahertz and 5 gigahertz and then some other bands.
All right. Well, I'll tell you what we're going to do. We have a lot of different projects for the show here that we do. And our next project is to work with you and Glenn, where we can make a contact on meshtastic from me to you, with Glenn being in the middle there, relaying. So, Glenn's about 140 miles from me, and you'll be about your hop will be about 2,000. I don't know, maybe less.
About 1,200.
All right, 1,200 miles. Okay, so Glenn, you're the middleman there. You're the most important one. I'll get the signal out, but you've got to get it over to Brett.
That would be a challenge.
Well, I get up on my
But
tower, and that'll get us
yeah,
halfway there.
You think it
yeah.
will?
Well, LoRa stands for long range, and that's what the radio that meshtastic
Yeah.
uses. But I don't
Yeah,
think it's that kind of long range.
yeah.
I don't know. Maybe if we amplify,
I think not.
we're
I
at
think not.
hams. We're allowed to
But
transmit a lot more.
All right, let's
no,
move
we're
on.
not.
Hey, we're going to go ahead and move
We
on here, and I'm going to introduce Stephen here to you guys. Let's see if I can get him on here. We'll just try to do a split screen like that. We'll do a full screen like this. Hey guys, I want you to meet Stephen Flowers, W2WF. He's out in Katy, Texas, and we're glad to have him tonight. And he's going to be talking to us about, I don't know how you say it, MMANA-GAL. MMANA-GAL. I don't know. How you say that, Stephen? You're muted,
Thanks
Stephen.
for having
There
me
we go.
here.
There you go.
And it's a very exciting program in its simplicity. I think that'll be the good takeaway here.
All
And
right.
it's about antenna modeling. I think it's called MANA-GAL. That's how I call it.
All right. Hey, before we jump in, let me go ahead and finish telling people a little bit more about you. You're a member down there of the BVARC in Houston. Now, I know you sent an email out to your members of that group. You got about 300 members in that group down here, is my understanding. So if anybody is in the chat room here to watch Stephen, let us know in the chat room if you're down in the Houston area watching tonight, and we'll just see if anybody came in here. But anyway, Stephen is a member of the BVARC, and also it's the Radio Club of Peru, I think. Now, how did you get involved with the Radio Club of Peru?
From Louisiana, and my mom was from there, and I was born there. So we travel quite a bit now in this phase of life, and pretty much go every year down to Peru. So I met up with the local amateur radio club there. Great folks, and we've done some POTA activations and some other projects.
All right, well, cool. I also know you're mostly, I guess, I don't know, maybe totally a CW operator, and you've been working with the Long Island CW Club. They're great for promoting CW, and we've had them on the show before. And I would imagine if you want to learn and bring up your speed on CW, they're probably the people to hook up with. Well, what do you think?
Things about the Long Island CW Club. I just got into CW about over 2 years, maybe going on 3 years ago, and it's just a question of practice, as I'm sure you know and your guests have mentioned. And the good thing about them is that we have Zoom meetings, and pretty much it's where we get together 3 times a week or so, and just practice. It's a very group, and we just go ahead and send song lyrics or send jokes, anything in a round robin configuration, anything that you can go ahead and practice transmitting. And of course, when it's not your turn, you're copying everybody else's transmission, so it helps your copying and your sending.
All right. Now, another thing you do a lot of is Parks on the Air. Now, I think when you have Parks on the Air, are you CW only?
SSB and Parks on the Air, and had a hoot. Took the activation of the south rim of the Grand Canyon over there in a portable station. That was the high point there. But then when I got into CW, it was more of a question of, okay, where's my signpost? LICW is good about what's your objective, your short-term, medium, and long-term objective. And pretty much I wanted to do Parks on the Air. And about a year, I started doing CW Parks on the Air, and that's what I've been doing pretty much all the time. To England, Peru, there, we activated the parks there using SSB, but other than that, it's CW only.
Okay, I'm sure you're having a lot of fun. And hey, being down in Texas, I don't guess you get it real cold. You can probably do parks quite a bit more than we can do up here. Uh, but hey, parks on the air. You do CW. You're in the radio clubs, but one of your interests, and that's what we're going to talk about tonight. One of your interests is in modeling antenna using software to model antenna patterns. I've tried the NEC. Is it NEC 4 or something like that? 4 NEC. I've tried that. I don't understand it. I'm getting too old to learn a new thing. So I'm looking for something a little bit easier to use that I might can use. I never had anyone really sit down and try to help or instruct me. I did download a few months ago the MMANA-GAL and tried it, and I didn't get very far with it, but I didn't try very hard. But I hope tonight. I think your presentation is going to show us a lot of things you can do with it, and tell us what you're going to do tonight, and we'll jump right into it.
And again, it's I just started using MANA-GAL from a Alan McCormick, the DX commander. He's very keen on this software, and he insisted that it was very simple to use. So on Sleet, I started with it, and I think the takeaway from this presentation will be like a wizard in our applications. A wizard will sort of walk you through the application in a logical, consistent way. And I think you'll see that this program indeed has that capability. So with that, if you're ready, I can bring up the presentation and we can go
Yeah,
from there.
yeah, let's do that. There we go.
The main slide there.
Yeah, it's there. Looking good.
And Tom and everybody online here, appreciate your interest in this software approach to antenna modeling. Again, my name is Stephen Flowers, call sign Whiskey 2, Whiskey Foxtrot. And the title of this talk is Practical Antenna Modeling Using MANA-GAL. And we'll touch on the strength in a bit. And but we'll go and what we're going to cover in this quick presentation. If folks have any questions, more than happy and field a question. But what the agenda, well, what practical questions do we want answered by antenna modeling? In other words, why are we doing this? What are we going to get out of it, right? And but before we do that, let's also look into if it's so good, this antenna modeling business. How was it done in the past? Always go to the past, to the literature, if you will, to see how folks tackle this problem. Is into we've seen the meteoric rise of software in the last 50 years. So what are the software options available out there for antenna modeling in an easy way, right? So with that segue, we're going to go ahead and go into our three workshop. We're going to actually do a practical model of a vertical antenna. I think this one is 20 meters. The number 2 exercise is going to be another practical model. This time is going to be a dipole antenna up about 15 feet. The program allows us to kick it up the ground and see how the radiation patterns are affected. And to be a practical model of a very popular antenna, the end-fed half-wave antenna. And to touch on something called optimizing functionality of this software. Up with questions and next steps. Where do we go from there? So first of all, what practical questions do we want answered? Is on the highlight in the yellow, the radiation pattern. And that answers the question really, in which direction is our antenna's best transmission and reception? Uh, have that, you know, the concept of radiation gain. What
Hey,
with
Stephen,
that, Rob?
let me ask you a question, Stephen, real quick. Are you talking into a microphone, and how far away it is? You're clipping a little bit. It's kind of like the beginning of a sentence. We maybe lose half a word, and then it comes in. Is it possible to maybe get closer to the microphone? I mean, we're 99% is coming through, but we're losing syllables at times.
Start the presentation.
No, I think we're okay to continue. I just wondered if you can get a little closer to it. And that way, we're losing about a half word occasionally.
But it may not be having much of an effect. So we'll proceed. And like I mentioned, radiation gain is going to be answering the question, how good is our antenna's transmission and reception in a particular direction? In other words, of our capability of transmission and reception. Want to consider the next concept is the elevation angle. Uh, of course, Callum McCormick, the ex-commander, is quite big on that because a 5-degree elevation angle may be actually a very good measure of will our antenna be good for DX, which is the question we're trying to answer. This model in our system now, in our program, model how other objects will affect our antenna. Say our antenna's out in a country location and we're close to a barn, a metal barn, or we're in a suburb and we have trees or the house itself. How will those affect our antenna? So computer modeling can help us with that. And how was antenna modeling done in the past? Uh, so let me take the time warp machine back to 1959. Specifically, the reference that I'm showing you here comes out of Popular Mechanics, a very known magazine of the time. And the April 1959 issue has this picture in it, which immediately draws your attention to, well, did they Photoshop something or what's going on with that tower? The it was actually built in this angular or this arc manner. And the picture is from the U.S. Navy, is Point Loma in San Diego. So what we're going for here is to actually measure this radiation pattern from a ship. And if you look in the lower right-hand side, you'll see what actually from a distance starts looking like the model of an aircraft carrier. And you'd be right, that's exactly what it is. So this was antenna modeling that used, their engineers at the time used brass ship models on a lead C, Popular Mechanics article from '59, and it's actually through a technique called inversion, they're able to actually model the radiation from the ships out into space. Of course, now we cut forward to today, how many years later. So we're saying, well, we're doing it better, right? Well, actually, yeah, that we still model in hardware. This picture right here comes from a microwave magazine article and about the U.S. Naval Research Lab, the NRL. And there, scientists have produced miniaturized radar antennas from CAD models using 3D printing. So again, it's all a question of how to address a problem given the resources that we have and the precision that we're expecting our antennas. So it's done in hardware. It was done, continues to be done in hardware. But what I want to orient this conversation to is software for antenna modeling. In other words, something that we could load on our laptop and just do a quick analysis of a quick geometry and how it might be affected by certain parameters. So with that, we go into, well, like Tom mentioned, there's the Easy Neck family of products, Easy Neck Pro 7, for example, used to be quite a few dollars, but now apparently it's free. And by the way, all of these programs seem to be based on the NEC, and that is National Electromagnetics Code or something to that effect. So modeling programs are fairly similar, if not the same. With Tom, I mean, I tried it when I first wanted to delve into antenna modeling. I didn't have much luck. And then following video, I tried MMANA-GAL. And before we say any more about MMANA-GAL, let's get this out, the elephant in the room. What is MMANA-GAL all about and where did you come up with that name? Well, start with a fellow named Makoto Mori, a Juliet Echo 3, Hotel Hotel Tango, a ham. And it's, of course, and analyzer, A. And the gal at the end is the G is coming from Igor Gocharyenko, Delta Lima 2, Kilo Quebec. AL comes from Alex Shevelev, Delta Lima 1, Papa Bravo. A very good graphic space or GUI. I think you'll agree to that after this presentation. And it's free. And it was created by ham radio enthusiasts. Having said that, this is the free version that we're going to cover in this presentation. There's a paid version, MMANA-GAL Pro, that has a few more features, but for antenna geometries we're wanting to model. Let me pause for a second. Do we have any questions or before we start going into the practical exercises?
No, I think we're okay. We can go ahead.
Exercise number 1 is going to be an antenna near and dear to my heart, which is a vertical antenna. I've got a DX Commander out back, so very, very very much. Yeah, it does have the issue with the radials, and so talk about it. So our vertical antenna model, as with anything in engineering or in physics, what we start out with is a free body diagram, if you will. And what I'm showing you here is exactly that, a free body diagram of our antenna relative to the ground plane. If you look down here, this hatched area down at the very base is the ground plane. That's what I'm plane, of course, laying right directly on top of it. We're going to be modeling 11 radials, about 10 feet to 15 long, each resting on the ground and uniformly arranged from the feed point. The radiating element is going to be in red, and that is our delta Z, or displacement in the Z direction for our vertical antenna. That's the radiating element. Here, red circle at the very base. As the legending shows right here, it's the feed point. So we're going to be feeding our antenna here. When this presentation was given at BVARC, the amateur radio club here at Brazos Valley, was where do we get this 5.1 meter? Well, let me just say that, first of all, we're looking at a 20-meter vertical antenna. We want to have a quarter wave above ground, so that'll be 25 meters. And app that I just happened to have on my iPhone, and I said, okay, model a 20-meter vertical antenna and tell me what the delta Z, or the displacement in the Z direction, should be. And it came up with 5.1 meters. We noted here that it's 16.7 feet, but we're this program. That's the one thing. And
Well, we're starting to break up a little bit on audio again. Not sure what's causing this. But let's go ahead and continue. I'm following you so far here.
Yeah, breaking up, Tom. It's like a short mic, because when his audio cuts, I can hear it very, very low. So it's like his connector's not good, or he's got a short.
This other microphone array. See if this will work.
All right, we'll give it a try.
Okay.
Yeah.
Can you hear me okay?
Yeah, we hear you. Perfect.
Is it better or is it the same?
Well, yeah, that's fine.
Okay. So let's go ahead and go into our practical exercise, which is going to be go into MMANA-GAL basic. And this one,
You need to bring the program back up, the PowerPoint back up on your sharing.
okay, are we seeing it right there?
No, not yet.
Okay, let me stop sharing. And try this one more time. Okay. Stop sharing there. We'll go the
Still not sharing yet, Stephen.
Mhm.
There we. Well,
We'll share right here.
yeah.
So can you see it now?
Yes.
Okay, so what I've brought up right here is MMANA-GAL Basic, as the upper left-hand corner indicates. And on the menu bar, you'll have the basic file edit options that we'll touch on briefly. But I'd like to point out, put your attention to these 4 tabs right here. And this is where this functionality like a wizard, starting from left to right, goes on. We start with geometry, view, calculate, which has the start button. In other words, this is the gut of the program that's going to generate the results. And then we view the far field plots, the azimuthal and the elevation. We'll talk more about that in 1 second. But since our goal was to model a 20-meter vertical, let's go ahead and get started. We are in the geometry tab, and we're going to type in here for name just to keep our thoughts in order. Vertical. 20 meters, 20-meter antenna. Okay, great. So the program, if we hit tab, it goes over here and tells us, okay, the frequency is going to be 14.150 megahertz. That's fine. And notice we have in the main body of this graphical user interface, we have what starts looking like an Excel spreadsheet. And if we highlight the first cell here, and hit enter, we end up with zeros for X1, Y1, Z1, which is one of the points of our antenna. And then the second point is going to be also 0, 0, 0 at X2, Y2, Z2. In other words, the X sub 1s and the X sub 2s are 2 distinct points that are going to define our antenna. As if you're tracking then the sub 1 point, we're going to leave in the origin at 0, 0, 0. The X sub 2, Y sub 2, Z sub 2 is only going to have one component. It's going to be 5.1 meters. Notice we're dealing with meters here. We hit enter, and that's all we have to do for modeling the simple geometry that we've come up with. We're going to leave this alone, and now we go into view. View is a view of our antenna that we just defined in geometry. If we move the mouse sideways while depressing the left-hand key on the mouse, you can see the rotation of the model. The x-axis and the y-axis have nothing, or 0, but there's a displacement on the z. If we hold the shift key and then the mouse down, then drag the mouse down, we actually are able to move vertically or sideways the entire antenna. This is overkill for a simple geometry like the one we have here, but you can imagine in more complicated antennas, this quality control step that we're doing right here is very good since we can see the antenna that we're going to be modeling. Now we haven't added a source, which is what we're going to do now. We place the cursor over the base of the antenna, right mouse click, and say add source to the beginning of the wire, this option right here. Once we do that, we notice that the program has added a little red circle, just like in our PowerPoint presentation, in our 3-point diagram. free body diagram. That circle in the legend denotes it to be the source. So that's where we're going to be applying our feed point. That's our feed point. That's where we're going to be applying our test voltage. If we go into calculate now, the third tab, as remember, there's 3 out of 4, so we're just about there. We are presented with the following. First, we're reminded of what frequency we're going to be modeling. Remember, we defined it in geometry. We left the default at 14.15 megahertz. That's fine. The next step that we see is a box for ground. Now, we have free space, perfect, and real. Free space is essentially an antenna radiating into the vacuum without, essentially out in space. And that's too much of an idealization here. So we're going to continue not with a perfect ground or anything like that, but with a real ground. So we select that option box and click on the ground setup button right here. Now, a dialog has come up that we're going to leave mostly default, so no need to worry about it. But I'd like to point out, say for example, we're modeling this antenna with the default parameters of a dielectric constant of 13.0. The program came up with that, we didn't add it. And the conductivity of the ground at 5.0 millisiemens per meter. And that's conductivity. Now, that's by default of an average type of ground. Now, if you look in the antenna handbook, the ARRL antenna handbook, you can actually, or online, you can actually get conductivities and dielectric constants for different types of ground. In other words, for example, if we model over salt water, say we're going to be taking this on a sailboat and we want to go ahead and model the salt water effect. Well, then we go ahead and change this conductivity to maybe 5,000 millisiemens per meter to make this more conductive. Or if we're in a desert terrain, we might want to change that conductivity to a very low value. Again, we're able to change this. I'm just saying that in passing. A very important checkbox to mark is this one right here, the radials. Use radials or don't use radials. And we checked it. It's just a toggle box, so we check it on. And remember, the number of radials that we wanted to model was 11. We can go ahead and enter 11 there. That's what we had for default, so we're good. Radius of the wire, we want to get that fancy, but I find that just that checkbox and 11 number of radials is enough. So we say, okay. So that's going to define our ground. The next thing to do is add the height. Now remember, our free body diagram had this flush on the ground. In other words, the feed point was flush on the ground. So we don't want to change anything away from 0. We could go ahead and use the drop down to select 5 meters, 7 meters. We're going to leave it at 0 meters. Again, in passing, we notice that the units are meters that we're going to have to use here. And we're going to have to do the conversion if we are keen to thinking on feet. As far as the material for our antenna for a radiating element, we select this drop down right here, and we see quite a few options. We're going to select copper wire. Notice that there's quite a few others, aluminum wire, iron pipe, and so on. But we're just going to go with a simple one, copper wire antenna. So we're at 0, flush to the ground, copper wire, real ground, we defined it. Now we're ready to click start. As soon as we click start, the program has run. It's amazing to me still how fast this will run and do these calculations. And I'd like to point your attention to this SWR value right here. It's showing 1.45 for our SWR, assuming feed point impedance, an input impedance of 50 ohms. And the resistance of the impedance, the resistive component, the real component of the impedance for our feed point is 35 ohms, which is fine. I mean, it's not 50 ohms, but it's close. If we now click on the far field plots, we notice this. Now, let me pause here for a second and bring your attention to these two plots. If you remember from I believe it's our technician and definitely general or extra exams, we see the azimuthal plot over here, which is like, I like to think of it as a crow flying right over our antenna. Remember, our antenna is at the origin right there. This is the XY origin, and that crow keeps on flying the other way right here. So essentially, that's an overhead view, if you will, an azimuthal plot of our antenna radiation pattern. And this elevation plot right here is, I like to think of it like you took a chainsaw to the middle of this azimuthal plot, and you came up with this cross section. It's a cross-sectional plot. And of course, with a vertical antenna, we're getting the two lobes, and we're starting to think that this might actually have the shape of a donut. But you and I think probably better in terms of 3D. So MMANA-GAL has that capability. That's 3D. And for the engineers or the physicists in the audience, that's FF or fast Fourier. All I know is that you click on it and you come up with this. There's our donut right there. And again, holding the mouse down, we can actually, view our radiation pattern. And more importantly, in what direction it would be strongest. Now, of course, this is an isotropic antenna pretty much, so it's going to be homogeneous in every direction. But in other antennas, we're going to have a preferred direction. And this might give us that insight of where our radiation pattern is going to be relative to the antenna. The antenna is that blue line, light blue line right there in the axis. It's a vertical that we did. So that is as simple as it gets. That is the modeling of our antenna. Once again, we went to the geometry tab. We defined our sub 1 coordinates, x, y, z, in 3 points, and our sub 2 coordinates, x, y, z, in 3 space. And we defined that one at 5.1 meters, whereas the origin was at 0. We double checked our geometry to make sure we weren't drawing any weird diagonals. By the way, now the program has actually also added this fellow right here, which is the current profile, the profile for the current on our antenna. And then we clicked on calculate, defined our ground, our wire, and our height, and clicked start. And after that, we were actually running, getting the results, and even in 3 dimensions. So with that, we've modeled a vertical antenna. So let me pause right quick and see if we can go to our presentation. And in our presentation, we had this exercise, which we just went through. The next exercise was going to be, try this. I think I should have done it from the current slide as opposed to this, but we'll get there here shortly. Well, actually, let's try this. Stop sharing. And then we'll go here and model our dipole antenna. Let me just do this one. And this, yeah. So if we do from current slide, there we go. So the practical exercise number 2 that we're going to do is modeling a 20-meter dipole antenna. Again, with our free body diagram for our dipole antenna, we have right here this hatched area, which is the ground plane.
Okay, now we're not seeing that. We're not seeing that. We're seeing the slide that says how was the antenna modeling done.
Okay, let's try this.
And by the way, your audio has not dropped a single time.
Oh, that's a good thing. Yeah, I'm trying the computer, okay, so if we do this, and now we share this to the entire screen. Okay, so I'm just going to leave it here at this screen right here. The practical exercise number 2. We're going to displace our antenna 10 meters or about 30 feet off the ground, and then it's going to be a dipole antenna, so it's as simple as it gets. We're going to go with a halfway from here to here. So since we're looking at a 20-meter dipole antenna, 20 meters times 1/2 is 10 meters for halfway. So it's going to be about 10 meters from tip to tip, end to end, and which means that one leg is going to be 5.1 meters. So that's this displacement of 5.1 meters. Again, the 0.1, let's not get hung up on that. That can be coming from an app that we put in, give me, a dipole antenna for 20 meters, and it'll give us 5.0 or 5.1 in this case. That's where I got that from an online calculator, if you will, or an app. So with that information, then we can go into, let me see, yeah, stop sharing, and now we share the MMANA-GAL program again. Let's start MMANA-GAL here. By the way, MMANA-GAL is started there. So let's go over here and share MMANA-GAL basic. It's giving us a bit of a hard time sharing that. So let's share the main screen, and we'll scroll across to MMANA-GAL. Share entire screen, allow, and there we go. So again, this is the MMANA-GAL screen again, MMANA-GAL basic like before, and here we're going to define our horizontal dipole. Again, we start with the leftmost tab, geometry. We name our horizontal dipole 20 meter antenna tab, and again he's going to go ahead and model by default at 14150, which is fine. We'll leave it there. We could change this again, and as before, we highlight the first cell of what looks like as an Excel spreadsheet, hit enter, and now we have our sub 1 point and sub 2 points, the 2 points that define our antenna. This time around though, we're going to go ahead and put minus 5.1 meters for the x direction of the first point, and the second point is going to be at a positive 5.1. In other words, it's going to be symmetric 10.2 antenna lengths. At least that's what we're trying to model. That's where the view tab comes in, to make sure we're not going diagonally or we mistyped something. And it seems like we got it okay. I mean, it's along the x-axis. The y dimension and the z dimension are 0. We're not modeling elevation now. We're going to model that in the next tab. But we do need to go ahead and add the source. So again, as before, we hover over the middle. We say add source to, in this case, it's going to be the center of the wire. The previous one, it was the beginning of the wire. Now we're going to go to center. As soon as we do that, again, we notice that we have a circle, a red circle in the middle. That's our feed point. Look at the legend, and it calls it our source. In passing, we notice that there's a capability in this program to add loads. So that would be for a future video, but we could actually add coils and loads such as this, more complicated geometries in other words. But not now. We'll just continue with this simple dipole. When we click on the Calculate tab, as before, we double check the frequency that we're going to be modeling, 14.15, that's fine. Now, the ground, we again go with real ground, and this time again, we click on ground setup, and here all we're going to do is we're going to leave the ground the same, but we're going to remove these radials because it's a horizontal dipole, so we're not going to be too keen on radials. We're not going to be too interested in radials. Now we said we're going to go ahead and do it at a height of 10 meters. So we'll go and put 10 right here. Again, this is a free text field, so we could actually pick from the drop down or just add it. And again, our material for our antenna is going to be no loss. I assume that's a superconductor. We're not going to be doing that. We're going to use copper wire. Fair enough. Click on start. And here we go. Again, our antenna now, our SWR, this parameter right here that we look at, is showing us an SWR of 1.88, assuming a feed point impedance of 50 ohms. That's not bad. It's less than 2. The resistance of our feed point, 73 ohms. Okay, it should be 50, but we can live with that. Let's look at what our radiation patterns are. When we click on the radiation patterns, we get something different than we did before. Now, this is a horizontal dipole, so we would expect it to have more of a different, azimuthally speaking, different radiation pattern than our vertical. And again, the left-hand side has our azimuthal plot. The right-hand side has our elevation plot. And once again, think of the azimuthal plot as where the cursor is. That's the crow. it's like a bird or something just overflying our antenna. It passes the origin and it keeps on going in this direction. Now, remember, we modeled it with minus x, x at minus 5.1 and 5.1 positive. So this is the axis of our antenna. And we're seeing that broadside to the antenna, we're going to have the highest gain, but not necessarily in the direction of the antenna itself. One other thing to mention, if where the cursor is, we go ahead and click it down, you notice what's come up. We can actually measure the gain up here at that particular point. This is actually useful for comparative purposes. In other words, the idea being not to get too hung up on the actual value of minus 0.2 dBi versus 4.4 positive dBi here, but relative. This is more of a null compared to this. A relative measurement is what we're getting here, not an absolute dBi that we want to hang our hat on. The other thing that we notice is right here, the cut across way. Again, it's like we took a chainsaw right across our azimuthal plot and we get this elevation plot right here. We start seeing that we can hold down the mouse and actually see at 5 degrees what this fellow would look like. So we start seeing if it's going to be a good DX antenna in this direction or in this direction, or if it's going to be more of a cloud burner antenna if it's radiating in this direction. But as before, you and I think better in 3D, so let's click on the 3D view, and we get this type of a flattened bean or some sort of a squished figure, which is exactly what we'd like to see. And if we see that we are on the x-axis here, you see the light blue right there? That's where our antenna is. So we're seeing that it's not going to be very good straight up, which is a good thing. It's not a perfect cloud burner. It's going to have strong lobes in those directions, but they're both going to be broadside to our antenna. Again, our antenna is aiming this way, and broadside to it, 90 degrees off, is where the strongest radiation gain is going to be. Okay, so now hang on. It would be nice if we could compare this to our previous display. Well, the previous display, there's a functionality here that actually says compare. These two sheets superimposed gives us this display, which is the same as what we have back there. But bear with me. If we say load MAB file, we can actually compare it to previous ones that we might have saved. And we save it by going in File and Save. But I saved the vertical 20 meter, so let's compare it. Now we can actually see something interesting. For DX, it seems like at 5 degrees, which would be right about here, the gain of the vertical antenna, which is highlighted in red over here, is better than the gain of this dipole, which would be right about here at 5 degrees. So that's a comparative feature that this program has to compare different antennas. Also, we could go ahead and say, well, okay, what about if we click on calculate and we change one of these parameters? What if we change the height? Maybe, we don't want to hoist this antenna up 30 feet. What if we just hoist it 15 feet? That would be about 5 meters. So we click on that. We click start. ISWR is 177. Resistance is 82. What about our far field? Okay, so just by lowering our antenna from 30 feet down to 15 feet, remember we went from 10 meters down to 5, then at that point we're seeing that this antenna is much more of a cloud burner than we were when we hoisted up 30 feet. So just from that, we're getting insight into the effect of delta C displacement, or displacement in the Z direction of our radiating element, and for this geometry. So with that, we're going to go to the final exercise, which may be a bit more challenging one. But any questions on this? Is this clear as mud?
Well, I'm following you, and it's interesting how you can just easily change things like the height above ground and see the different patterns here. I
Now,
think
if you
that would
like
be
this one,
good.
Tom,
I think that would
yeah,
be good. To I know lately, the last month or two, I've been experimenting with antennas, and I can watch them on the analyzer, and as I pull them up in the air, you can see a big change when you go through 10 feet, 15 feet, 20 feet. So there are some points there that probably make sense in stopping. I mean, height is not everything.
exactly, exactly. So I think you're going to love this final exercise that we're going to do. Let's go ahead and close our MMANA-GAL, and if we go here to our presentation, I'm just going to go like this. I think it'll
Okay,
be
that's
simpler
fine.
just
That's
to go
fine.
one space down. This is going to be the practical exercise number 3. This is the last one, so I'm not going to bore you anymore. But this one is a cool one. This is called the end-fed half-wave antenna. Now, the free body diagram that I've got here was done in PowerPoint, I think it is, or LibreOffice. Anyway, so you'll have to forgive my version of a tree. Maybe it's a surrealistic tree over here. But that brown bar right there is the trunk, and those green gear-looking things are supposed to be leaves. So that's a tree. So with an end-fed half-wave, of course, very popular now because if you remember, it's got a single point of support up on a tree, and it's that fellow right up there, up in that area. The wire may be 67 foot long. I believe that's what we usually are advised to make. And then we have this thing called a 49-to-1 transformer right here. That's a 49-to-1 transformer. One other thing that we had is this little red pigtail at the very bottom here. In other words, right there. Unfortunately, this cursor is turning into a crosshairs there, but right there's a pigtail, and that's the counterpoise. So then the question that can be asked, what if we model without this antenna, without the counterpoise? Will that have an effect? I think that's going to be some interesting insight.
Oh yeah.
So our free body diagram again shows the ground right down here, that thatched area or hatched area at the very bottom. That's a ground plane. The tree, my version of a tree right up there. We have about a displacement of about 1 meter, which is about 3 feet. That when we usually go to parks on the air, we'll go ahead and tie on to a tree with our 49-to-1 transformer, and that's about 3 feet maybe. We can change that, but just say it's going to be 3.3 feet or something. And then we go 67 foot all the way up to a tree. So for this, we use, I guess we use trig or Pythagoras or something, assuming 67 foot up here, what's our displacement in the x direction, and what's our displacement in the z direction? Well, from exercises that I did before, I modeled that to be 17.68 meters in the x direction and 10.218 meters in the z direction. So let's go ahead and model that in MMANA-GAL. And we'll go ahead and launch the program here. And there we go. Once again, we're presented, we start the MMANA-GAL basic, and we're starting in the view over here, configuration. We can go to geometry. And now what we're going to go here is go for the end-fed half-wave antenna. And notice we're not putting a 20 meter or anything like that, because this is going to be it's going to be resonant on multiple frequencies, and I think that's going to be interesting to see. So as usual, we go ahead and go into here to the first cell, hit enter, and we see that we have our sub 1 point and sub 2 point, 2 points in 3 space that define our antenna. And we're going to start at the origin there, 0, 0, 0. We're not going to change that. Our x2, though, where we want to take that one to, is going to be 17.68 meters. Hit enter. And our z2, our y2 is going to be 0. In other words, we're going to be flush or coplanar to the xz plane. I'll show you in a minute here with the view presentation. 10.218. That's what the calculation showed to be, to account for a 67 foot length wire, which we're going to start and see how that works. Great. So now, as before, we click on view to make sure that this makes sense, makes physical sense before we start, running our modeling. We again hold it the left mouse key and the shift, and we can actually move this around. We let go of the shift key and we're able to move it. And we see right there that our antenna, that black line, is coplanar to XZ. In other words, it's flat against the XZ plane. Once again, we just do this, and we see we don't have any displacement in Y. So that's okay. That's what we wanted to model. Before we leave this screen, normally we define our source. So we hover over the base of this fellow. We right-click at source to the beginning of the wire. And there we are. We shift, left mouse click to lower this down, and we see right there our 0, or our little red O, which according to the legend is the source. So it seems like we're modeling the right geometry. Now let's go calculate. Okay. For this one, let's make sure our ground hasn't changed. No, we're not considering radials, and we're good. So I'm going to just assume a basic type of ground. The height, remember it from last time, but we want to do it at 1 meter. Remember, we said it was going to be about 3 feet off the ground that we're going to tie our 49-to-1 transformer to. Oh no, the drop down doesn't show a 1 meter. It says 0 and 3. But hang on, what if we just change this over here? The guy said this was a free text, so yep. So it is a free text, and we just changed it to 1. So it took it. So we added a height of 1 meter off the ground, and we're going to say model it of copper wire. Okay, great. So now, as before, we just mindlessly say start, and we got garbage. Why? Well, because we're getting an SWR of 1 to 12,273. But wait a minute. For an NFET half wave, remember, we have a 49-to-1 transformer. Well, how do we model that? Well, the input impedance of this model that we just ran is 50 ohms, but that's not correct. If we say 1 to 49 is 50 ohms to what value? Well, 49 times 50 is 2,450 ohms. So our input impedance is going to be 2,450 ohms. So we need to change that. For that, we go to Setup, and there's the option under Setup called Setup. And right here is where we change the standard resistance of the feed point. So we go ahead and put in 2,450, okay? And now we say, okay. Great. So the program just ran. The good news is we're now modeling a feed point impedance of 2,450 ohms, purely resistive. But the SWR continues to be 1 to 252. That's not good. So what could be wrong, right? I mean, as engineers, we go ahead and troubleshoot. Let's go back to our view. And at this point, one thing we notice is, you know what, we're not modeling that counterpoise. We should, we don't have anything back here. It's like 0 counterpoise. Well, let's model a counterpoise. So how do we do that? Well, we're going to model a second element. We go to the next row and hit enter. And here we have the sub 1, the origin is going to still be the original point, the point number 1. But point number 2, along the x direction, we're going to say minus 2 meters. Now, why minus 2 meters? Because when I go to the park, I usually have a coax that's about 6 feet, maybe 10 feet, all the way from my radio all the way to the 49-to-1 transformer. So let's model it to be a 6-footer. Why 6? Because remember, this is meters, so we have to multiply times, 3.2808 to get, feet. So it's right about 6 feet right there. Okay, let's look at view, see if we didn't do something wrong. And if we move this sideways just by using the left mouse button, we see that we indeed have put in our counterpoise, our little pigtail right there. Okay, cool. So that seems to be working. Now if we go to calculate, leaving everything the same, we haven't changed anything, meters, so that should be 1.0. Right? 1.0, okay. And copper wire, and now we say start. Okay, so just, two possibilities. One, we had a height of 10 meters over here at one point. Let's see if we put that to 10.
just to make sure we got this right. Click start. 1.69. So the delta Z, the displacement in Z, is not having much of an effect. But we said that we would go ahead and put our transformer 1.0 meters. So we go there, and we get an SWR, assuming a feed point impedance of 2,450 ohms, purely resistive, of 1.31. Now we're talking. Now, the resistance, of course, is going to be 2,225. But wait a minute, we're expecting it to be 2,450, so that's okay. That's what that 49-to-1 transformer is going to do. It's going to knock this down to 50 ohms to make our radio happy. That's fine. Let's look at the far field plots. Okay, now we're seeing something interesting. Again, azimuthal plot on the left, elevation plot on the right. The crow flies over. Our antenna is along the X direction, and it seems to have some lobes here at 20 meters. And it's got this cut across shape that sort of looks like a cartoon shoe or something. We go to the 3D, and we start seeing something more interesting. We just move the mouse sideways, and we start seeing our antenna starting in the origin and going all the way up to that tree. And away from that antenna, in other words, our 49-to-1 transformer being here, towards the 49-to-1 transformer, we're getting this lobe right here that is pretty much hugging the ground. So that might be a good DX direction right there for our end-fed half-wave. But what about these other two lobes over here? Well, those other two lobes may be a little bit more cloud burning, but not totally. If we close this, yeah, they're going a little bit high, but not that high. There's one other trick I'd like to show you here, and that's this button right here for elevation. Remember at the beginning of the presentation, we mentioned that Callum McCormick, the ex-commander, likes to use a far field elevation angle of 5 degrees for his models. And the reason being that is a good criteria for DX antennas. We click OK, and what this has done now is just essentially cut right at 5 degrees here, and it gives us this type of azimuthal plot. Gain of 3.31 in this direction. There's a null there of -10. And I'm looking again up here at the gain, -5 up here. So that's -4.6. That over here is -3.3. So definitely getting more of a gain in this direction, which is good because that'll be the DX direction. And this is at 5 degrees that we're seeing now. So now with this, we can actually compare it to, say, for example, the vertical. We say over here, we just clicked on, by the way, on this button right here to compare, load MAB file. And from a previous run, I did the vertical right there, open it. And you can see that the end-fed half wave for 5 degrees is a little bit better than the vertical. The vertical is this red right here that looks like a donut, whereas in this direction, the end-fed half wave is going to be better DX. So just with this basic insight, basic entry of parameters, we're able to get some good insight on this application. One other thing, remember we mentioned that this would be a multi-frequency antenna. Well, how do we do that? What do we have to change? Well, not much. Remember, this is a drop-down over here for frequency. Again, I'm in the Calculate tab. Click on this right here and say, let's model it for the CW portion of 40 meters. In other words, 7.050 megahertz. Click Start. 2.49 SWR. Okay, not terrible. I mean, it's still under 3, but look at our far field plot. Totally changed now. Very much of a cloud burning state, antenna here. We haven't changed the antenna. It's the same antenna, but now at a different frequency, it behaves different. Our azimuthal plot is now very symmetric, and our elevation plot, or chainsaw cut across view, is looking more like a cloud burning configuration. Let's continue with this. What about if I model, I don't know, I like to go to the CW portion of the 15 meter band, say 21.050. Let's select that, and that's up there. We click Start, everything else being the same. This antenna should work okay, less than 3.0 in SWR for this, but now the radiation pattern is quite a bit different. So we're getting insight about how this antenna behaves in different frequency ranges. One question that we get asked a a lot is, what about using this in the 80 meter band for the local nets around the Houston area? When we click that and select 3.550, click start, SWR goes crazy, 539. So what the program is telling us is, the modeling is telling us is, this is not a good antenna to model, not a good antenna for 80 meters. Don't expect it to work on 80 meters. So with that, let me pause before we go into the final bit of this presentation, which is going to be the optimization functionality. Any questions or any doubts? Am I going too fast for, you might have any questions or anything?
I haven't seen any questions. I've been trying to follow it
Okay.
myself. It appears in looking at you, all these steps, if you can only remember about 6 or 7 steps to where to click, you can model just about any antenna. I mean, you don't have to be a rocket scientist here. If you can just remember those
And
6.
that's what,
Yeah.
exactly, that's what surprised me, Tom, because, antenna modeling in EasyNEC is a heck of a lot harder. To me, at least, it was. When I
Oh,
saw
yeah.
MMANA-GAL, I'm saying, okay, well, that's the 4 tabs. Okay, well, it's like a wizard. You start from left and go to the right, and you get your answers. So it just, yeah, I liked it.
Yeah.
Okay, so we'll go into optimization, and that's the last thing I want to show you here.
Okay.
So click on optimization, and we get this dialog right here. It's a little bit cluttered, so just bear with me. Let's split it into 2. The top part, top 50%, and the bottom part, the bottom 50%. Essentially, the top part is what we're going to be optimizing for, with left being not optimized, and right, like I'm moving over here the SWR tag, over to the right. That means optimize for SWR. The match is not being optimized for. I'm going to say optimize for that too. And these other ones, I'm going to say, don't worry. In other words, the front to back, the current and the current, I guess that's reactance, the gain, not caring about that. I just want you to optimize SWR and match. Now, for the bottom part, the bottom 50%, as we called it, this is the parameters that we're going to be tweaking. Okay, fair enough. Click on that. That was a left click, by the way. And click on wire. We can change other parameters, leave that for later work, but for wire right now. And he's going to, let's say, wire 1. And we're going to say, for example, we had something for X2. And remember, the value for X2 was 17.68. And then wire here. Again, with wire 1, we're going to optimize the other parameter. This one was Z2. And again, the value is populated here. Remember, we entered 10.218. Now, before we click start, let's put some sensible minima and maxima here. In other words, we're going to go from 0, enter, to about, I don't know, 50 meters. I mean, we're not going to be doing that, but let's just say, just optimize in that window. And this one here, the Z displacement is going to go from 0, enter, over to, I don't know, 50 meters also. And then we say start. So even with that, we're able to get some sort of optimization for this 80 meter antenna configuration. Once we go to geometry, we notice that it's changed our values considerably. In other words, this is not the same antenna anymore. Remember, for this value for X2, we had 17.68, and for Z2, 10.218. So I guess this is telling us that, yes, we could still make it work at 80 meters, but we're going to be changing the configuration quite a bit. So let's go back to 17.68. And the other value that we started out from our model, from our free body diagram, 10.218. Once we have that, we can go over here and change the frequency over here to 14.050. And we say start, 1.69, okay. We could optimize that. And we say start. Okay, we went from 1.69 to 1.27. Okay, and if we go to geometry, it's changed it from, we started out with 17.68, now it's 17.78, and the delta z, or the z displacement, was started at 10.218, now it's 10.368. In other words, the program is giving us the insight to say, instead of 67 foot, you might want to cut that wire a bit long, and then the mathematics works a little bit better. You get a better SWR if you're able to do that, to get it a little bit longer. And of course, that's probably what we do anyway. So this is the type of insights that we get from this program, how much wire to cut in some cases. And we could do similarly for this one right here, the length of the pigtail. We could optimize that. But it's simple, like what I just showed here with the optimization tag. Click on it, you go to wire, say wire, and then we'll go ahead and remove these other ones. We're not going to optimize wire 1. So we say delete this line. Okay, here. We'll say wire, and it's going to be wire 2. And then we'll say, I think this was X2. Wire 2. I have to hit enter. And X2 shows us a value of -2 meters. Remember, that was our 6-foot pigtail. So say we go from -10 to, I have to remind myself to hit enter. Enter, and then we go a maximum of 0. So all we're saying is, everything else being the same, what is our pigtail value? I mean, do we need to consider a longer pigtail or a shorter one? We say start. And it went ahead and gave us 1.29 for our SWR. And if we click on geometry, it just increased it right over 6 foot. So 6 foot is probably a good length for our pigtail. So we're getting all these insights or suggestions to try from our very simple model, very simple program. So that's what I wanted to show you, Tom. I mean, it's just like you're saying. It's like a wizard. You go here, change a few things here, validate that your design is correct. Here, make sure your ground is correct, wire and elevation risk, displacement in the Z direction is what you want, and hit start. And then see the far field plots for some insight. So that's pretty much the presentation. I mean, I'm really keen on any questions or anything else that folks might have.
Okay, very good. Do we have any questions in the chat room that you'd like to ask Stephen? I mean, I'm seeing it's pretty simple. 6, 7, 8 clicks, and you can model something. But I might have to practice with it a little bit. Let's see.
Mm-hmm.
Yeah. Brett's saying even that have to experiment with it with this some. One of the things I discovered here recently. I could put a lot of that information into AI, like the X.com AI or the Chat GPT, and it'll actually come back and give you some modeling for an antenna. You can input a lot of those things in here. Have you ever tried that?
No, I haven't, but I think now you piqued my interest. That's something to try.
Yeah,
Absolutely.
just go.
And again, it's a tool, and it's a software program, a modeling program. But now with the AI tools that are becoming available, absolutely, we need to try them out.
I tell you, AI is getting so smart. You can actually go in there and you can say, model me an antenna, a vertical antenna for this frequency, 4 radios, and show me the pattern, and it'll do it. Now I don't know how it compares to this program here, but it's probably using this program to do it. I don't know, man.
It seems like this NEC, the National Electromagnetics Code, seems to be at the core of a lot of these programs. So maybe it is indeed what it's using.
Yeah. Well, I think we're all going to have to play with this a little bit. I still couldn't just jump in here right now and do it, but as I mentioned, it seems pretty straightforward with just a few steps. Once you get those steps down, you can do it.
Yep,
Yeah, it
I
doesn't
think
look
so.
that
I
hard.
think so.
What was that? Who was that? You?
I said it doesn't look that hard.
Yeah. All right. Well, Glenn, next week we're going to have you model some antennas right during the show, man. So you
As
better
long as you
practice.
have me modeling antennas and not clothes.
Yeah, yeah, okay, we can do that. So we're going to test you. Yeah. All right. Well, I don't see a lot of questions in the chat room. There was some discussion following you there about the height of different things like the balun and so forth, and it was interesting, Stephen. Thank you very much for showing it to us. Now this is recorded on our channel, and people will be watching this, from now on, maybe years from now. So we'll pick up a lot more people that will be tuning in and seeing your presentation there. We really thank you for doing it for us.
Well, thank you very much. Hopefully it was useful.
Yeah, I think it was. I think it was, and we do have people in the chat room asking about where to download it. They've already Googled it and they put a link in there. So you've stirred up some interest for sure. There's people going to be downloading it. Yeah, very good. All right. Well, hey, you're welcome to stick with us the rest of the show if you want to, even after the show. We usually hang around a few minutes. Or you can leave, whatever you want to do. Don't want to tie you up down there. But thank you again very much for being with us there. And guys, we'll be right back in just a moment. Let's all go over to ICOM and check out the IC705. The IC705 is an HF 50, 144, and 440 megahertz multi-mode portable transceiver. It gives you base station performance and features in the palm of your hand. The IC705 is a perfect sidekick and QRP companion. This compact rig weighs just over 2 pounds with RF direct sampling for most of the HF band and an IF sampling for frequencies above 25 megahertz. It includes a 4.3-inch touchscreen with live band scope waterfall, 5 watts with a BP272, and 10 watts with a 13.8 volt DC. Integrated GPS with antenna and GPS logger. Supports QRP, QRPP operations. Heard it, worked it, logged it for the love of ham radio. For more information about ICOM's amateur radios and a locator dealer, please visit icomamerica.com/amateur. All right, I tell you what, guys, we started a little late tonight. Let's see, with the pre-show. We'll probably go about 20 minutes longer tonight. And that'll give me the correct time to put on the radio station, and that'll be good. So, hey, let's do this. I asked Brett to check into, we got some new frequencies. I don't know if you guys know that or not, but Ham's got some new frequencies, and Brett is going to tell us all about them. So, Brett, come on in here and tell us about them.
Okay. Well, yes, we got a little bit of new spectrum. And this was a pleasant surprise because we were worried that we were actually going to lose some. Let me go ahead and put up a screen which shows the current allocation and the two proposals that were put forth by the FCC, and then what ultimately was done. So here we are. This is the current 60-meter band as we know it now. It's split up into 5 2.8 kilohertz channels, which hams can transmit with up to 100 watts. Now, hams are considered secondary users of the band, which means that if we detect non-amateur traffic on a channel, we have to yield to it. Now, other countries went by a band plan that was established by the World Radio Conference in 2015, which is this middle band plan here, which consists of a wide band, not a single channel, in the middle of the range, and doesn't have the channelized sections out here on the outside. Now, after the World Radio Conference, the ARRL proposed that we keep all of the channels as is and gained access to the channel in the middle, which hams and other countries were using, and be able to do 100 watts PEP on all of them. Sound like a great idea. Now, the FCC has now gone along with the rest of the world. The new allocation does do sort of what the ARL proposed. It gets rid of the middle channel, which is channel 3, and superimposes a band of 15 kilohertz of spectrum, which is not channelized. You can work any mode here: phone, CW, RTTY, Olivia if you want, FT4, FT8. But there's a catch. When the FCC approved it, it limited this center section to the 9.15 watts PEP, which is the equivalent of 15 watts EIRP. That is, if you had a perfect isotropic antenna, then you could put 15 watts into it. In real life, 9.15 watts, the way they quote it here, is what you'd be allowed to put into just a regular half-wave dipole. Now, the new rules, the way they're set up, may cause problems for people who are using FT8, because it's traditional to use FT8 on channel 3, which is now overlapped by this new range where you can only put out 9.15 watts. So I expect that there are going to be some gaffes. There are going to be some hams that don't know about the change. We're going to be transmitting with too much power in this area. But the good news is it will only be over the little slice of this band that is, that was there before. That was channel 3. But we will still have channels 1, 2, 4, and 5 as we did before. And outside of that range, where again, I think there's going to be some confusion for a while, we will have more spectrum on which to play. Now, the new rules don't go into effect instantly. The rule is that FCC rule changes do not go into effect until 30 days after their publication in the Federal Register. And to my knowledge, they haven't appeared there yet. So once that happens, your printed band plan chart or mouse pad or picnic table cover won't be accurate anymore. There also may be a wait before some manufacturers provide new software for their radios that let you access the new spectrum, because some of them are pretty restrictive and will only let you transmit on the channels. But if you're a QRPer and you work POTA, and so the 9.15 watts is not a constraint for you, it's what you do anyway, this is fresh new spectrum, and it's on 60 meters, which is a very nice band. It's good for DX. You can go all over the world with it on surprisingly low power. So this could be a lot of fun, and I'm looking forward to trying it, probably with QRP myself, because it'll open up some new opportunities for DXing. And that's what I have on the rule changes.
All right. That's exciting, man. I'm going to have to try that out. I think I've only been on the 10 meg band here just a couple times, but that's interesting. Be something new to do.
Yep. And I don't know what the FT8 users are going to do. They won't be able to transmit with much power there, so they may move to one of the 4 remaining channels. Channel 3 has been the standard one, but they might move to one of the others. I guess we'll see whether the ARL suggests something or if it just happens by consensus.
Yeah, my ICOM radio doesn't even have that band, but you can operate it. I think you have to put that frequency in memory, and then you can operate it from memory. Is the way the ICOM radio works.
Mm-hmm. Yep, there are different ways to unlock new frequencies on different radios. Some of them have once you put in the Mars mod, actually completely unlock them. Some of them have specific unlocking patches that you can get from the manufacturer.
Yeah. Yeah. All right. Well, hey, thanks for that report there. I think I don't know. The last time we had any band changes was, oh, I'm trying to think of what they called it. The licensing where we got the what 17-meter band and the
The work
24 meter.
bands.
The work bands,
Yeah,
yes.
it was called. I think FCC called it. Well, you know what? This probably had nothing to do with it. I remember, I guess back in the 70s, they called it incentive licensing. That's where they broke the bands up for advanced and general and so forth. But I guess
Yes.
maybe that didn't have anything to do with the new bands.
Yeah. Well, these bands, the new swath of spectrum that we got is already in use in the rest of the world. And I guess the FCC figured that, hams should have the same privileges as hams from other countries. So I'm glad they did it.
Yeah, yeah. All right. Well, hey, I'm looking at your picture back there. What are you doing with those landscape lights? That picture of your landscape lights behind you there.
Oh, that's my lair. That's my space lab in space.
Oh man. Well, all right. What are we going to talk about? We got about 10. I know what let's talk about. Let me show everybody what I did here. I'm just going to take 1 minute. That's all. And it's going to take Glenn to argue with us here about this. Let's see if I can show you here what I did here, man. Let's see. Yeah, all I got to do is find the right thing to click on. And there it is. Guys, I got my meshtastic working, and here it is here. I know nothing about it. Actually, with it just sitting on the Venetian blinds here in the window, you can see I'm receiving people, and in
Yes,
fact,
you
I'm receiving quite a few people here, with not much going on out here now. You know, but all I know is I can read a few things here. Battery voltage. Hey, here's one. Bartlett, 11 miles for me right here. This guy's, hey, here's a 25 mile for me, Glenn. Things are starting to pick up a little bit. 3 hops, 25.6 miles. Let's see what else we got here. 7 miles, 10 miles, 12. Okay, 13 miles. Oh, I don't know how to work it yet. You know, let me ask Glenn just one quick question here. Glenn, this is the little button here. I guess that's messages or something. And
Right.
and there's the channel I guess I've got set up. Now this guy may have sent me a message. I don't know. He's showing up under messages, but I sent a message to this guy. He didn't respond. No, wait a minute. I don't know if I sent one to him or not. I don't know if what are these messages? What are these right here under me? That's not even under me.
All right. When you sent that message to AD4GG, remember you got an error message.
Yeah, I did. Well,
The message did not go through, so that's not a relevant. You sent a message through. A lot of those probably never went through.
well, none of them went through. I don't think. Now, how do I know that message didn't go through?
Right.
How do I know it didn't go through?
Because when you click you click on it, it might tell you. But
Here it
at
is.
the time,
Here it is.
it told you. All right. You see the cloud mark.
Yep.
Cloud has a dash through it.
Yeah.
It says it did not make it.
Yeah. So let me ask you a question. It didn't make it, but why is he showing up here?
Because you sent it.
Okay. All
It
right.
shows you whether you sent it or not. It
Okay. All right. So it shows I sent it.
does not show you he got it. The other
Yeah.
screen shows you that he got line through the cloud.
Yeah. Your
This
audio's.
is not the most intuitive user interface.
Yeah, I would
Yep.
say so.
And if you increase your hop count, you have a better chance of reaching people. because it might percolate through
Yeah,
the
he's
mesh
at
and get
7.
to them.
I'm at 7. That's the max.
Okay. Yes.
My understanding is
Yeah.
that, well, I read where it might go through better if you're lower. One thing is the channel. There's channel utilization, and I'm reading and studying, and where I'm hearing if the channel's at 27, 28% or higher, almost no messages will go through.
Right.
So that sounds like to me they need to up the bandwidth a little bit. I don't know. Anyway,
That's
so
for the ISM band. It's 28 kilobits, period, end of story.
yeah, okay. Well, we need to fix that. Would you write a letter to the FCC?
Well,
I mean, after
I'll
all,
write a
you're
letter to the FCC tomorrow,
yeah. I mean,
and
after
I'll
all,
sign it with Brett's name.
you're writing a book about this. You're the authority. You need to write the FCC and tell them we want more bandwidth for that. Okay, so all these people here, basically, I'm seeing, like this guy's on now.
Correct.
He's on now. That's me. I'm on. And then this guy here's on now. And there's 6 minutes to go. 7 minutes. 8 minutes. All right. So, oh man, I'm just not sure what this thing does, but I got one.
You're where it does it. All it does is text, basically, simply, stupidly.
Yeah.
That's it.
Well,
Period.
it's just fun putting this little thing the size of a quarter out in the window and picking up people from all these miles away, And when I get that,
Well, the key is all you got to do that one hop. You make that
yeah,
first loud, boom. It's dependent on the rest of everybody else point. And if you scroll up to the top, you saw the mode of one of those was red. The bottom one, scroll down, or the Eastern Trail Pipe.
Glenn, you're breaking up now. Just like earlier, Stephen was breaking up, but after he changed mics or did something.
You're running too many streams.
No, we're down to we're down to 2 streams.
2 weeks ago.
We're down.
Into weeks ago, you're running too many streams.
We're running 2 streams right now at 900 megabits.
All right, listen to my words.
Yeah.
We ran into this 2 weeks ago, and you had to kill a stream to make it work.
Yeah, well, I've killed those streams tonight, and it's still doing it on you right now. Now, he cleared up. He was perfect.
No,
I don't know.
Did not.
Huh?
I could hear him breaking up.
I never heard him break up after he changed that.
Yes, he broke up very briefly, nowhere near as bad as before, but he was still breaking up.
All right, we got to call a chat room poll here. Glenn says he broke up. Tom says he didn't break up after he changed the mic out there. I thought he was really loud and solid. Did he break up after he changed, or was he breaking up the whole time? Give us an answer in the chat room, and whatever the answer is, we're gonna stick with it. Glenn, if I lose, I lose, but I never have lost before. See, look at there.
Yes,
Stephen sounded good after the mic change. Look at that. He was okay after
Now
he
here,
changed
the
mics.
very-
There's two people that said he didn't break up any after he changed. After
I'm
the mic.
running my normal config here.
Yeah. So far, we've got. I noticed some brief drop out. Who did that? Who did?
What Bill said.
Where's the admin? I
Look
want
at
you to
what Bill
bump
said.
bump that guy off the chat room. I don't know what. Okay, it's 3-1. Okay. Case
Hey,
closed.
my lead is 1.
Case closed. Case closed. I won that one. I'll just put that in the books. I won it. All right. Well, look, that's all I want to talk about on meshtastic right now. It's just a fun thing to look at right now. Yeah, and I can say I've got a meshtastic, and in a few weeks I'm going to put it up at about 80 feet in the air, and I'm going to see what it does then. And I did read that we're talking about very weak signals here, and a lot of people talked about if you're in your house and the signal's weak, you may not get out good. If I get this thing up here 80 feet in the air, people might start hearing it, I don't
It's
know.
going to change, but you are refusing to listen and apply here, Tom.
Well,
If you make the first hop to any, you will get all the rest of the hops. 80 feet at your location don't mean diddly.
what do you mean don't make diddly? What are you talking about?
If you play on your screen that says 2 or hops, you're in the cloud.
Yeah.
What
Well,
difference does
well,
80 feet
well,
make? You've made
well,
the second
well,
hop.
well.
It makes it, it makes it. If it doesn't, it
I don't
doesn't.
know. Maybe I'm hearing better than I'm talking. Maybe it's getting out less than.
If
You
you
know.
are making that first hop, it does not matter beyond that.
I'm talking about the first hop. Maybe I'm hearing the first hop, but I'm not quite getting to it.
Do you remember Pacquiao?
Yep,
Do
yep,
you
yep,
remember
yep,
Packet
yep, yep,
Radio?
yep, yep,
Yep.
yep, yep. All right.
Do you remember Packet Radio?
Packet. Oh man, it took me 5 days to get a message across Arkansas on Packet. Yeah.
I rest my case.
Yeah. Are you telling me that I might eventually get out? It just taking 5 days to get from here to the first node?
I am telling you that if you make that first hop, whatever you do on your end no longer matters.
Okay. Well, you're the experts, so
The hop.
you're the experts. Although we did take a vote.
I'm telling you, there's not that much going on there.
All right. You need to fix your audio.
You need to fix your end because I'm fine.
Oh man.
Anyway, thought I might mention something about the rules. If you
Yeah.
use your ham license to transmit on the ISM bands, the rule is that you can go up to 10 watts PEP, and that's PEP. You can use a high gain antenna along with it.
Yeah.
Because this is a spread spectrum emission type. You can't go. At first, I had thought that the rules would let you go up to 1.5 kilowatts. No, that's not correct.
Yeah.
The correct limit for hams is 10 watts plus whatever your antenna gain is. Listening to part 97,
But
section 97.313.
but
anyway,
if we do go to the 10 watt in the ham license part, I think we're missing out on all the non-licensed people that are on there, right? We won't be able to see them or talk to them.
That is correct.
they will be able to see you, but you're not supposed to talk with them.
Now, come on, how's that going to work?
Time out. It's not you're not supposed to. It's you're physically unable.
Did
They
you
are
hear?
not
all
allowed
right.
to talk in the ham modes.
Okay, did you hear that, Brett? They're not supposed to. You get
You
that?
use that supposed word.
Yeah.
If
let's see.
they are partying, they cannot talk to part 97.
All right, Brett, does that include the 22 meter hyper band, which is limited to around 5 milliwatts? That's the question that came in.
I don't. That's for spread spectrum modes in general, but I don't know. Let's see. I'm looking in the chat here. I don't. I'm not familiar with that band, so I couldn't tell you off the top of my head. I could research that.
All right.
I'm not even a 22 meter band.
I realize what's happening. Glenn's Vox is cutting in and out. Yeah, yeah, yeah.
No,
I'm going to look that up.
It's the internet link somewhere.
All right.
Oh, okay.
The fact that Bill
Hyper
heard the
is
cutting
another
out too.
ISM band. It's a shortwave radio beacon station run by a hobbyist under Part 15 rules.
Yeah, it's
So
a
there's
whisper.
gonna be limits to that. I'd have to look them up.
It's tracked on Whisper. It's just like 20-meter Whisper, but it's 22-meter, non-licensed, and you can see it on Whisper. So, I guess if you're not licensed, you can, still use it and track it on the whispernet.org, maybe.
Yeah. I'll have to look at Part 15 to see how much power is allowed.
Yep. All right. Well, I don't have anything else here on my list to talk about, so I guess we'll go ahead and shut the show down. We'll stick around. I got to argue with Glenn just a couple more minutes, so you guys won't stick around. But we're going to go ahead and close the show. And guys, we appreciate you watching and listening tonight. You've been listening to Amateur Radio Roundtable, a show about ham radio and shortwave. We're also on shortwave, WBCQ on 7490 kilohertz on Thursdays. And our show can be seen on W5KUB.com on Tuesdays at 8 p.m. Central Time. Good night, everybody. And we got Glenn here and his cats. Let's see what they're doing. Let's see.
They're sleeping.
Yeah.
So you're saying I can ask this cat any question?
The cat is connected to the computer. You just type in the question, it will read his mind. There the answer comes.
You're the man! I've been looking for this for weeks.
All right. Also, if you guys, have not followed us much, we had a visitor on the show the other night. Here he is.
Hey, Tom, I just wanted to let you know that when we get our mission to Mars going, I want to schedule you and your show to be the first to communicate with us in space. By the way, I never miss an episode of Amateur Radio Roundtable on Tuesdays nights on W5KUB.com.
All right. Well, I just wanted to know that. Elon, he calls in just about every night to the show. I don't know where he was tonight. All right, guys. Good night, everybody. We'll see you next week.